Hello everybody, welcome back to the chapter Quadrilaterals. In this period, we will see more examples related to midpoint theorem. Let us see the first question. ABCD is a quadrilateral. Here it is. In which P, Q, R, and S are the midpoints of the sides AB, BC, CD, and DA. So all these sides are equal because these are the midpoints. Fine. Now the first part we have to prove is SR is parallel to AC. SR is parallel to AC. This is what we have to prove first. For that, of course, this is related to midpoint theorem. So whenever you consider, whenever the given condition is midpoint, directly go to midpoint theorem. So first we will see the triangle DAC. SR is half of AC by midpoint theorem. Also, SR is parallel to AC again by midpoint theorem. What was the midpoint theorem? Or just let's have a quick review. Midpoint theorem says that a line joining the midpoints of two sides is parallel to the third side, and also the new line that we joined the midpoint will be half of the third side. Well, let's move on to the second part. PQ is equal to SR. We need to show PQ is equal to SR. For that, let us consider the triangle ABC. In triangle ABC, again, we can see that P and Q are the midpoints. So PQ is equal to half of AC by midpoint theorem. And also PQ is parallel to AC, again by midpoint theorem. PQ is half of AC, SR is half of AC, which means these two conditions are the same. So from equation 1 and equation 2, we have both half of AC, half of AC. So from 1 and 2, we can see that SR is equal to PQ. And also we can see that SR is parallel to AC, PQ is parallel to AC, which means SR is parallel to PQ also. SR is parallel to PQ. So one pair of opposite sides are equal and parallel. So we find that PQRS is a parallelogram. Therefore, PQRS is a parallelogram because one pair of opposite sides are parallel and equal. That's what we have to show PQRS is a parallel. In this example, ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD, and DA. Since it is a rhombus, all sides are equal and the midpoint cuts into two equal parts all over. So all these parts are equally divided by the midpoints. That's what we have. And we have to show that the PQRS is a rectangle. For that, first let us show that PQRS is a parallelogram. For that, we consider the triangle ABD. In triangle ABD, we know that PS is half of BD. And PS is parallel to BD by midpoint theorem. Also, let's call this as condition 1. Also, in triangle BCD, we can see that BD or QR is half of BD and QR is parallel to BD. Again, by midpoint theorem, let's call this as condition 2. From 1 and 2, we can find that right sides are equal, so left sides will be equal. PS is equal to QR and PS is parallel to QR. Why is it so? PS is parallel to BD. Again, BD is parallel to QR. So finally, PS is parallel to QR and they are equal. Therefore, PQRS is a parallelogram because one side of opposite sides are parallel and equal. So we found it is a parallelogram. Now we have to find it is a rectangle. A parallelogram is a rectangle if one of the angle is 90 degrees. So we are going to prove one angle is 90 degrees. So this is what you have to prove. Before we prove this one, first we have to consider in a rhombus, diagonals meet at 90 degrees. That is an important fact about rhombus. And square, diagonals meet at 90 degrees. Very important fact of a rhombus. For that, we consider the quadrilateral OMRL. In OMRL, we can see that OL is parallel to MR because it is a part of BD and QR. Also, OM is parallel to LR because in triangle ACD, AC is parallel to SR by midpoint theorem. So OM and LR are the parts of it. So we can see that OMRL is a parallelogram because both pairs of opposite sides are parallel. These two conditions are different. Here we only talk about one pair of opposite sides, but here both pairs. Here only one pair. Okay, now we got this is a parallelogram. And you know in a parallelogram, opposite angles are equal. But angle LOM is equal to 90 degrees because the diagonals of a rhombus meet at 90 degrees. Rhombus diagonals meet at 90 degrees. Now we know that angle LOM is equal to angle R because opposite angles of a parallelogram. Therefore, angle R is equal to 90 degrees, which means PQRS is a rectangle because since PQRS is a parallelogram with one angle 90 degrees. Let's move on to the next example. ABCD is a rectangle. So remember opposite sides are equal and PQRS are the midpoints. So these two sides are equal at the same time these two sides are also equal. Again, these two sides are equal because in a rectangle opposite sides are equal. Now we have to show that PQRS is a rhombus. So to show that it is a rhombus, we first show that it is a parallelogram. So once again, considering the triangle ABD, we know that PS is parallel to BD by midpoint theorem. Also, PS is half of BD, again by midpoint theorem. Also, in triangle BCD, QR is parallel to BD, and QR is equal to half of BD. So which means, therefore, PS and QR are parallel from equation 1 and 2. Also, PS is equal to QR. Therefore, PQRS is a parallelogram. One pair of opposite sides are equal and parallel. Now, to show that a parallelogram is a rhombus, we have to show that any two adjacent sides are equal. For that, let us consider the diagonal AC. So we know that BD is equal to AC because diagonals are equal in a rectangle. So from the triangle ABC, we get PQ is half of but we can write PQ is half of BD because they are equal. So we get PQ is half of BD. PQ is half of BD. We already know that half of BD is QR. So therefore, half of BD is QR and half of BD is PQ. So let's name this as equation 3. And this is equation from equation 2 and 3. We get PQ is equal to QR from equation 2 and equation 3. So if adjacent sides are equal in a parallelogram, PQRS is a rhombus because adjacent sides are equal. Well, moving on to the next example, ABCD is a trapezium in which AB is parallel to DC, BD is the diagonal, and E is the midpoint of AD. These two sides are equal. A line is drawn through E parallel to AB intersecting BC at F. So EF is parallel to AB, which means EF is also parallel to DC because lines parallel to each other are parallel to each other. Show that F is the midpoint. So we have to show these two are equal. For that, again, we have to apply midpoint theorem in the triangle ADB. We can see that EG is parallel to AB given, and E is the midpoint. So we have to apply the inverse of the midpoint theorem. A line joining the midpoint of one side of a triangle parallel to the third side meets the midpoint of the second side. So here we can see that, therefore, DG is equal to GB by inverse midpoint theorem. Next, we have to consider the second triangle here. In triangle BDC, we can find that GF is parallel to DC given to us, and DG is equal to GB from above. So again, by inverse midpoint theorem, we can see that therefore BF is equal to FC because inverse midpoint theorem. That was to be shown. That means F is the midpoint of the side BC. That's all for today, and we'll continue the next question in the next period.